Hi, welcome to a deep dive into one of the Django's most powerful feature called signals. Signals provide it. Okay, let's get into the project details and we will be getting into topics one after another. So coming to the Django signals. Django signals provide mechanism for deep coupled applications to get notified when something else occurred in the framework. Okay, let me come up with an example. So when a user created their account, the post save method on the user model can fire a signal. So based on that, a method or a function called profiles app will be listening to that event. So whenever the signal has been fired, the profile app will take that event and builds a user's profile. So this is a classical example of Django. So this will be helpful in connecting multiple parts of the system. Yeah, this is my project called enterprise order management. So I have refactored the architecture from service signal based to service layer architecture. So I will tell you what's the problem with the Django signals and why did I choose the service layer architecture. So coming to the Django signals, it works by a method called spooky action at a distance. Okay, let me show you with an architecture. Yeah, this is the signal based architecture. So the VR controller, the method dot save will be listening for the order model save. So in this application there are two models. One is user model, I mean not orders model, and another one is user statistics model. So whenever the order model has been saved, for example, say a user has made some order and we need to save that into our order model. So signals will have something called signal dispatcher. So it will take the signal and invokes the receiver. Whoever listening to that signal will be receiving that signal. So the signal receiver function and it will update the statistics and it will be storing in our user statistics model. So this is a typical architecture of a signal based model. Okay, let's coming to the some other details. Yeah, core engineering concepts demonstrated. One is architectural refactoring, moving business logic from Django signals to an explicit service layer. Because signals is an implicit layer method. So if we want to still understand about Django signals, let me come up with another example. So you will be assuming this is a magic in the framework. It works in different parts of the application, but it will be not supposed to use in production ready systems. So whenever a user has created their order, we need to update the inventory and send a mail to the user. So this application will contains about 15 plus background workers. Then what will happen if one of the receiver or the background worker fails? The entire system will fail. I mean, we don't know where is the error happened. So that's why we'll be refactored to the service layer architecture. And another thing is database transactional integrity. So I have used atomic property diversity of acid components called transaction.atomic. It will be a built-in method given by Django's transaction and performance optimization. So we have heard about something called n plus 1 query problem. Suppose you want to get a list of items, that is a one query, and you want to access all the items within that list. So this is the n queries sent to the database. So this is an bad bad thing in databases. We need to optimize this by using Django's bulk create and f expressions. So f expressions can be helpful to compute the mathematicals directly on the database server without loading into Python's memory. So these are the examples, and coming to the code. This is my project structure with orders as an application and signals project as a project. First you need to set up your signals by adding your application name and as well as your database URL, and that's it. As well as the in production ready systems, we need to change your secret key to be not exposed in. Okay, let's get into the orders. So I told you there are two models. One is order, saying about what is the type of order placed by the user. I have used a user model because it is an inbuilt model. It will give us complete authentication. So we don't need to think about creating our custom logic for user from scratch. So order model contains of three entities, I mean three variables. User, and you have seen that this is a foreign key. On which one? User model, the built-in model, and the total the amount spent by the user and the status. For default, a product will be setting into pending, and user statistics. So we have seen that this is a one-to-one field, and this is a foreign key. So the difference between foreign key and a one-to-one relationship. Foreign key is nothing but one-to-many relationships, and a one-to-one field is it is strictly one-to-one field, because a user can make multiple orders, but a user can have only one user statistics profile. That's it. So this is our typical model, and Django will convert these into Postgres SQL tables. It will be stored as orders underscore order. So that's why this is an ORM based tool. So we don't need to write our schema for SQL, and we need to register the application in apps.py. If we are using signals, I have refactored the system to a service layered architecture, so I have removed that signals. I have commented out the code because I have refactored to the service layer architecture. So this is typical use case of the Django signal. So it consists of main methods are receiver. This is the function who is listening to the sender. Who is the sender? The order model. And post whenever a save has been happened to the order model, this method will be run. For example, update user stats on order save. So instance is nothing but the real object, the data that has been changed. So we are showing the variable in instant.user and the stats for objects.get or create. So this works in two conditions. One is to get or select or create. So once they have been created, we will be incrementing the order count and decimal field. So this looks fine for up to now, but this becomes bottleneck or dangerous when we need to handle 1,000+ records or 10,000+ or millions of records in a database. So this is a service based architecture, service layer based architecture. So we will be using transaction.atomic operations because whenever an order has been placed, we need to update the statistics also. So what happens whenever due to the error or network drop, the order has been placed, but the user statistics have not been placed. This is the bottleneck in the signals. So we have wrapped the logic in the transaction.atomic function. So either all has to be succeeded or nothing has to be, or all has to be failed. So if the order has been successfully placed, then only we will be incrementing the order count of the statistics. So that's how we will be implemented. And I have benchmarked the performance between signals layer and service based layer. So you can check it that. I have created a custom Django management command to check the performance of both these things. So yeah, this is the n+1 query problem with a signal based architecture. So for example, let's say we have to create 1,000 records. So for everything we will be incrementing and we are adding the value. And this is the optimized service approach because we are using something called bulk create. You can see this method. And we have used something called f expression because they will be computing the mathematical operation directly on the database server, not on the Python's memory. So yeah, the speed up time will be calculated by the signal time upon service time. Okay, let's see whether the containers are running or not. Yeah, both the containers are in the running state. Let me show you the real world, the performance of both the service based and signal based performance architectures. We need to enter into the application and we need to run the command python manage page. Okay, sorry. And I have created the test for both these services and signals. I'll show you that. So just create a testing whether the order creates also updating statistics or not. Yeah, you can check the signal approach time is nearly 5.676 seconds and the optimized service time is 0.5 seconds, nearly 100 times faster than the signals based approach. So in this way, I have reduced the time of the database performance. Okay, let's test the application. Yeah, all the tests have been successfully executed. So we are just bypassing the signals to work of the bulk update. Just we are creating the bulk orders and sending all the things at a time. Yeah, this is how I just implemented signal based, service layer based architecture by knowing the drawbacks or dangers of Django signals. Okay, that's it. Thank you.